transform Mars into an Earth-like planet. You'd warm it up. The fast way is drop thermonuclear weapons over the poles.
It sounds like the plot of a golden age sci-fi novel, or perhaps the plan of a Bond villain. It's imprinted on t-shirts, it's been tweeted into oblivion, and it's been discussed on late-night talk shows. The idea: nuke Mars. Specifically, drop thermonuclear weapons on the Martian polar ice caps to warm the planet and begin the process of terraforming. It is perhaps the most audacious, controversial, and distinctly Elon Musk idea in the entire aerospace conversation. The goal is noble: transform the red planet from a freezing, irradiated desert into a second home for humanity. But the method is explosive. But beyond the memes and the headlines, what does the actual science say? Is this sheer madness, or is it a stroke of brutal, necessary genius? Today, we are bypassing the hype and diving deep into the physics, the geology, and the logistical nightmare of the nuclear option. We are asking the hard question: if we actually did it, would nuking the poles really warm Mars? Before we start dropping bombs, we need to understand the target. Mars is currently uninhabitable without a pressure suit. It is a vacuum-frozen desert. The average surface temperature is a bone-chilling -63 degrees Celsius, -81 degrees Fahrenheit. But the bigger problem is the atmosphere. It's unbelievably thin, less than 1% the thickness of Earth's at sea level. This means two things. First, if you stepped outside, your blood would literally boil at body temperature. Second, the atmosphere is too thin to trap heat. Mars suffers from a runaway anti-greenhouse effect. Any heat from the sun hits the surface and immediately radiates back out into space. To fix Mars, we need a blanket. We need to thicken the atmosphere with greenhouse gases to trap solar heat and raise the pressure so liquid water can exist on the surface. This is where Elon Musk looks at the Martian poles. The poles of Mars are massive reservoirs of frozen volatile materials. There is water ice, yes, but layered on top of and mixed within that water ice is a massive amount of dry ice, frozen carbon dioxide, CO2. CO2 is a potent greenhouse gas. It's what's warming Earth right now. Elon's logic is straightforward. All the ingredients for a warm atmosphere are already there. They are just locked away in the freezer. We need to defrost them. Fast. The proposal isn't to blow up the planet. The idea is to detonate thermonuclear devices, hydrogen bombs, not on the surface, but above the polar ice caps. The goal is to create artificial suns. The immense thermal radiation from continuous nuclear detonations would vaporize the ice. Crucially, because the atmospheric pressure is so low, the dry ice wouldn't melt into liquid. It would sublime, turning instantly from a solid into a gas. In theory, this massive injection of CO2 gas would thicken the atmosphere. The planet would begin to trap heat. That heat would melt more ice, releasing more gas, creating a positive feedback loop that eventually leads to a warm, wet Mars. On paper, it's elegant physics. In reality, it's where we run into the buzzsaw of planetary science. If you remember nothing else from this video, remember this. The central problem with nuking Mars isn't the nukes, it's the Mars. The entire premise of this plan rests on one assumption: that there is enough frozen CO2 at the poles to actually make a difference. For decades, planetary scientists debated how much CO2 was really locked up there. Elon's plan assumes a thick scenario, that the ice caps are hiding vast, deep reserves of dry ice. But recent data has practically crushed that hope. The definitive mic drop on this topic came in a 2018 study published in Nature Astronomy, led by Bruce Jakosky, the principal investigator for NASA's MAVEN orbiter. MAVEN has been studying the Martian upper atmosphere for years. Jakosky's team took inventory of every possible source of CO2 on Mars. They looked at the poles. They looked at CO2 trapped in minerals in the crust, carbonates, and they looked at gas adsorbed onto surface dust grains. Their conclusion was devastating for terraforming enthusiasts. They calculated that if you perfectly vaporized all the available CO2 at the poles, you would only double the current Martian atmospheric pressure. That sounds good, until you realize we are starting at 0.6% of Earth's pressure. Doubling it gets us to about 1.2% of Earth's pressure. To have liquid water and a temperature you could walk around in with just warm clothes and an oxygen mask, we need at least 60% to 100% of Earth's pressure. Nuking the poles gets us barely a fraction of the way there. The study concluded that even if you somehow vaporized every molecule of CO2 available on the entire planet, not just the poles, but baking it out of the rocks globally, you'd only get to about 7% of Earth's pressure. The verdict from NASA? Mars does not contain enough CO2 to be terraformed using present-day technology. Nuking the poles would make Mars slightly less cold and slightly less vacuous, but it would still be a frozen, lethal desert. You'd just have nicer weather for your funeral. Let's put aside the lack of CO2 for a moment and look at the mechanism itself. The bombs. Sometimes people imagine one or two big bombs kicking off a chain reaction, but that's not how heat works. To sublime billions of tons of ice, you need an astronomical amount of continuous energy. Elon Musk himself has suggested it would require a continuous stream of detonations to keep the heating process going. We aren't talking about a couple of nukes. We are talking about thousands, perhaps tens of thousands, of the largest thermonuclear devices ever constructed, detonated over years or decades. Then there is the efficiency problem. A nuclear weapon isn't a space heater, it's a blast. When a nuke goes off, a huge percentage of that energy is released as kinetic energy and high-energy radiation, X-rays and gamma rays, that would blast straight out into space because there is no thick atmosphere to contain it. You would certainly vaporize some ice, but you would also be blasting huge amounts of dust and pulverized rock into the stratosphere. On Mars, global dust storms actually cool the surface by blocking sunlight. You might accidentally create a nuclear winter that counteracts the very warming you are trying to achieve. You also run the risk of just blasting the existing atmosphere off the planet. Mars has low gravity. If your explosions are too violent near the top of the atmosphere, you might accelerate gas particles past escape velocity, thinning the blanket you are trying to build. Now let's look at the logistics. This is where the Elon factor usually shines, making the impossible affordable. But this stretches even credulity. Currently, there is a strict international treaty, the Outer Space Treaty of 1967, that explicitly forbids placing weapons of mass destruction in orbit or on celestial bodies. Even if you argued these weren't weapons, but terraforming tools, the geopolitical nightmare of one company or one nation building an arsenal of thousands of hydrogen bombs and loading them onto rockets is significant. Imagine the launch manifest. If a rocket carrying a multi-megaton warhead blows up on the launch pad in Texas or Florida, you have an unparalleled environmental disaster on Earth. The safety protocols required to launch thousands of nukes would be paralyzing. Let's assume we get them there and they work perfectly. We have now irradiated the poles of Mars. Hydrogen bombs are cleaner than old fission bombs, but they still use a fission primary to trigger the fusion secondary. They create radioactive fallout. The poles are exactly where we want to go to access water ice for drinking and making rocket fuel. If we irradiate the planet's primary water source, we have shot ourselves in the foot before we even land. We want to terraform Mars to live there, not to create the solar system's largest toxic waste dump. Finally, there is the ethical question. We still do not know if Mars has indigenous microbial life beneath the surface. If life exists there, it is likely huddled around subsurface water ice near the poles for protection. Carpet bombing the only potential biosphere on another planet before we've even confirmed it exists is a tough sell for the scientific community. So, let's review the scorecard for the nuclear option. The pros. It's fast, it utilizes energy we know how to create, and it targets the right raw materials. The cons. It's illegal under current treaties, logistically terrifying, potentially creates a radioactive environment, and, most importantly, according to the best data we have from NASA, it simply wouldn't work, because the raw materials just aren't there. Elon Musk is an engineer who solves problems by applying brute force physics. Need to get to orbit cheaper? Replay the rocket. Need to dig tunnels faster? More power to the cutting head. Nuking Mars is the ultimate brute force application. It's applying a sledgehammer to a problem that might require tweezers. So, is Elon wrong? Scientifically, almost certainly, yes. The data just doesn't support the fast, terraforming scenario. But perhaps being right isn't the point. Elon Musk's greatest skill isn't just engineering. It's shifting the Overton window, taking ideas that seem insane and moving them into the realm of serious debate. 10 years ago, landing orbital-class rockets was a joke. Now it's routine. By loudly proposing we nuke a planet, he forces the world to take seriously the idea of changing a planet. He forces us to do the math, to run the simulations, to send the orbiters to check the ice levels. We probably won't nuke Mars. If we ever do terraform the red planet, it will likely be a slow, agonizing process involving orbital mirrors, manufactured super greenhouse gases, and centuries of patience. It won't be a blockbuster explosion, it will be a slow thaw. But we are talking about it. And in the grand scheme of making humanity multi-planetary, that conversation is the first step. What do you think? Is the nuclear option worth the risk? Or is it a dangerous distraction from realistic exploration? Let us know down in the comments. If you want deeper dives into the actual science of the red planet, make sure you subscribe and hit the bell. Thank you so much for watching the video so far.